you liked 5.0 and or were able to handle 5.0, then 5.1 should be good for you. It's the exact same thing twice.
Yay.
Same problem. Why?
Wahoo.
Why? Okay. Here's the deal. This may or may not be true.
It's true, so we should.
Then we have to do it to find out.
So this
Good job, Mackenzie.
is, basically what we're doing is we are trying to prove whether or not this is true. If we wanted to prove this was not true, there's a very simple way to do that. Put a number in. If we put a number in and it turns out to not be true, is that enough justification that this is not an identity?
Yes.
Yeah, that's all it takes. All right, and that plugging a number in that makes this thing not work, that's called a counterexample. And you may not have used that word in geometry. Like for instance, all triangles are right triangles. True?
False.
Why not?
Because you can draw.
Draw one that's not. Equilateral triangles are not right triangles, so there would be a counterexample. So for this particular problem, if you could find an x for which this was not true, you would have just found a counterexample. You plug a number in, if they don't match, it's not true. If the directions say, prove that this identity is true,
Then that sucks.
and it turns out to not be true, that would be mean and cruel. Because you're trying to prove two things that aren't true actually are equal to each other, and they're not, and that sucks. So for instance, maybe you get down to a point where it says sine equals cosine. True statement?
No.
No, but if the direction said prove that this is true, and you got it down to sine equals cosine, that's a bad thing. That means either you screwed it up, or they were really poorly written instructions. So what we are going to do, and I will promise you this, if I give you a problem like this and say prove that this is true, they will be equal to one another. You just have to go through the steps to show that they are. Because if
Can we get that in writing?
What's that?
Can we get that in writing?
Hell no. Learned my lesson. All right, but here's the big thing. The fact that we have not yet shown that they are true means that we really do have a question mark in between. And because there's a question mark in between, one of the biggest rules of algebra cannot be applied. Way back when you were just a little tyke in algebra, some of you may have done train tracks.
One can't do the same thing to both.
Whatever you do to one side, you can do to the other. That's a fundamental rule of algebra. Doesn't apply because we don't know if they're equal to one another. So I can't do that. So for instance, if it would be to your advantage to divide through by tangent, you can't. Because we don't know that they're equal to one another. So dividing through by something is considered an illegal math move. In other words, we have to treat each side independently. And our goal here is to do one of these two things. Either make one side look like the other side already does, or screw around with both sides until they match each other. As soon as we can get these two things to match one another, our proof is over. So when you look at a problem like this, you got a pretty messy left side and a pretty easy looking right side. The 2 tangent of x, is it worth trying to make the 2 tangent of x look like this?
Gosh, no.
Probably not. Might we be able to take this and make it look like that?
Yeah.
That's probably an easier trick. So essentially what we're doing is the same stuff we did yesterday, but now there's an equal sign. So I want to take this side and I want to clean it up, and hopefully by the time I'm done cleaning it up, it looks like that. So that's basically section 5.1. So on this particular mess right here, what route might you go?
With the cosine. Switch the cosine.
Sine and cosine? Secant could become 1 over cosine. Cosecant, 1 over sine. So you know what's kind of cute? Over there, I already have a sine over cosine, which is
Tangent.
tangent. Now, if I was changing this to sine over cosine, I might not change that to tangent yet, but because my right side's got tangents in it, probably that's a pretty good move to call that a tangent of x already. So that would be a good looking step number one.
Flip and multiply.
I can flip and multiply that first fraction. Not bad. So this would become sine over 1.
Looky there, it's sine.
That's sine over cosine. That's another tangent. So now I got tangent of x plus another tangent of x equals 2 tangent of x. True statement?
Yeah.
Starting to look like it. Now to finish the proof, and I know this seems kind of like way too much effort and your hand might get sore. The very last line of one of these proofs should be left side, right side, exactly equal. So don't leave it like that. Take the last step, which says 2 tan x equals 2 tan x. And the universal symbol for I am done with my trigonometric proof is a smiley face and a candy cigarette.
Why is there so much of the candy cigarette?
Because candy cigarettes are coated in sugar.
Yeah, but it doesn't come out.
You guys are so naive. Can you walk into like a store and buy candy cigarettes still?
Yeah. There was a fresh
don't
one.
have
Any small town like in America, you should be able to find like a Walmart or Walgreens that still sells them.
There was a freshman trying to sell them to me in the cafeteria.
Did you buy them? What the hell's the matter with you? Buy them.
Why wouldn't you?
Exactly.
If a freshman.
Is he getting some right now?
Candy cigarettes.
They're awesome. They come, they're wrapped in a cellophane.
No.
She was trying to sell me individual ones.
Why do you have those?
He
They're
literally
candy
has to.
cigarettes. Who doesn't have them?
No, they're like the white ones, right?
I thought it'd be easier to make this one.
I got a sweet picture of Megan McNamara.
Maybe two.
Have you never had a candy cigarette?
I have.
Very good.